my name is Andrea, and today I will introduce linear relationships. Linear relationships appear in the world around us in the areas of finance, production, and construction. In linear relationships, we have an independent variable. This is a variable that is not changed by another variable. This variable will cause change in another variable, and is usually represented by x. We also have a dependent variable, a variable whose value depends on other factors, and is usually represented by y. For example, as the size of a floor increases, the amount of concrete needed to form the floor will also increase. Thus, the independent variable, size of floor, causes change in the dependent variable, amount of concrete. In a linear relationship, we have a steady change in the independent variable, which results in steady change in the dependent variable. This is usually expressed as y is equal to mx plus b. Notice that the degree of x is always 1. A linear relationship will always be expressed with a straight line. It could be increasing or it could be decreasing. We also have to consider slope in linear relationships, which is the measure of the steepness of a line as we move from left to right. We could have a positive slope, a negative slope, zero slope, or an undefined slope. The x-intercept is the point where the line of the equation crosses the x-axis. On a graph, the line that is horizontal is the x-axis, and the vertical line is the y-axis. The point where my graph crosses the x-axis is the x-intercept. Notice that at this point, the coordinates are 10, 0, and so the coordinate of y is always equal to 0. We also have a y-intercept. This is the point where the line of the equation crosses the y-axis. Notice here my graph is crossing the y-axis at this point where the coordinates are 0 and 10. Notice that x is equal to 0. So with an x-intercept, y is equal to 0. But with a y-intercept, x is equal to 0. Let's look at an example. World Finance Company calculates a borrower's monthly payment by dividing the sum of the amount borrowed and the total interest by the number of months in the repayment period. We'll assume the interest rate is 9% and the repayment period is 24 months. First, let's identify the independent and dependent variable. The independent variable is what is not changed by any other variable. In this situation, the independent variable is the amount being borrowed. The dependent variable is the variable that depends on some other variable. Your monthly payment would depend on the amount that you're borrowing. Therefore, monthly payment is dependent variable. The next thing we'll do is we'll assign variables to represent these values. We will let A represent the amount being borrowed, and let's let M represent our monthly payment. We can write an equation to express the relationship between amount borrowed and monthly payment. We're told that the monthly payment is calculated by dividing the sum of the amount borrowed and the total interest by the number of months in the repayment period. Therefore, M, our monthly payment, is equal to the sum of amount borrowed, A, and the interest. Well, that's 0.09, A. And we're going to divide this by the number of months in the repayment period, which we assume is 24 months. The next thing we might want to do is create an input-output chart for monthly payments when the amount borrowed is $1,000, $2,000, and $3,000. Here's an example of that input-output chart. Notice that input is the amount being borrowed, or the independent variable, and is x. We've listed $1,000, $2,000, and $3,000. The output is what we calculate the monthly payment to be. We've calculated by rewriting the formula for monthly payment and then plugging in that amount where we see A. And so if the amount borrowed is $1,000, we see the monthly payment will be $45.42. If the amount borrowed is $2,000, we see the monthly payment is twice that, $90.83. If the amount borrowed is $3,000, we see the monthly payment is $136.25. As the amount borrowed increases, the monthly payment also increases. This is an example of a linear relationship. We might want to graph this linear relationship on a coordinate grid. We've scaled the x-axis so that it can represent the values $1,000, $2,000, and $3,000. And we've scaled the y-axis so that it can represent values as low as $45.42 and as much as $136.25. So when the amount borrowed is $1,000, we know the monthly payment will be about $45.42. When the amount borrowed is $2,000, we see the monthly payment will be $90.83. And when the amount borrowed is $3,000, we see our monthly payment will be $136.25. The x-intercept and y-intercept in this situation are going to be the same. The place where this line would cross the x-axis is going to be at 0, because if y is 0, that means the monthly payment is 0, and so we must have borrowed $0. Also, if our monthly payment is 0, obviously we borrowed $0. Slope can be thought of as rise over run, or in other words, the change in y over the change in x. In this case, y is changing by $45.42 each time we add $1,000, and so the change in y is $45.42. The change in x, well, we're increasing the amount borrowed by $1,000 each time, and so the change in x is $1,000. This is the slope of our equation. So therefore, slope indicates how much our monthly payment will increase with each incremental increase of the amount borrowed. I hope that you've come to understand linear relationships a little bit better. Thank you.